Today's lesson, applying composition of transformation. Composition of transformation is basically simplified by doing more than one transformation, like maybe we're going to do a translation to move something right 4 up 5, and then we would reflect it over the y-axis, right? I'm doing like a combination of different transformations. Now there are a few transformations that have a specific name after them. For example, this first one here is called a glide reflection. It is which we transform first, and then we are going to reflect parallel to the original transformation. So in this case, it shows kind of going up and to the right a little bit, and then we are reflecting parallel over a line that is parallel to that original move. Okay. Now this generally won't happen much unless we are doing kind of a vertical or horizontal movement and then flipping over either x-axis or y-axis just for simplicity in that reflection piece. Otherwise it can get pretty complicated. Vertices of ABC are 3, 2, 6, 3, and 7, 1. Find the image and result of triangle ABC after the combination glide reflection, and in which case we've got xy, where x is minus 12 and y stays the same, right? And so by doing this movement, right, we're basically going 12 to the left, and then we're going to flip over a horizontal line. So in this case, right, you're subtracting 12 from the x. That's literally all we're doing in this first transformation. So 3 minus 12 gives us negative 9, 6 minus 12, negative 6, 7 minus 12, negative 5. Just moving the x values, the y values stay the same. And that is our prime points, A prime, B prime, C prime. And now we are reflecting over the x-axis, which is a reminder, x stays the same, y flips the sign. And so now all those positive y values flip to being negative. So negative 9 stays the same now, positive 2 becomes negative 2. Negative 6 stays the same, 3 becomes negative 3. Negative 5 stays the same, x becomes negative 1. For our final pieces, A prime, double prime, B double prime, C double prime, being negative 9, 2, negative 6, 3, and negative 5, negative 1. Now graphing, here's how this will look. So we start with points A, B, C, and then these are moved 12 to the left, right? X minus 12. And there we have A prime, B prime, C prime. And now flipping over this x-axis is going to give us these points, right? 2 away, minus 2, 1 away, 1, and 3 away, 3. And so our final answers here are C double prime, B double prime, A double prime, which should be negative 9, negative 2. Looks to be negative 5, negative 1, and negative 6, negative 3. Just double checking. Yep. So we match. Right. If you need to graph that, feel free to pause and copy it down. Continuing on, suppose ABC is translated 4 units down and then reflected in the y-axis. What are the coordinates of the image's vertices? Right, so using the same point, so kind of copy paste in here. Right, 3, 2, 6, 3, 7, 1. But this time they have us going 4 down, so this is y minus 4, and then flipping over the y-axis, which is going to be x flips the sign, y stays the same, right? So doing these quick, 3, 6, 7 stays the same, 2 minus 4, 3 minus 4, 1 minus 4, there's our primes. And now it's flipping over the y, so now these 3 becomes negative 3, 6 becomes negative 6, 7 becomes negative 7. And again, this is a negative x, y move. Right, so there's our coordinates of the vertices, not graphing this one. But then it asks for how could we go backwards? How could we do a glide reflection the other way? Now recognize for 1 second here that, right, what did we do? We minus 4 to y, and then we negative 1 times the x. So we still need to do this piece first, this minus 4 to the y. Sorry, it looks like y minus y. right? But instead of minusing 4, right, because we're going this way, we're going to plus 4. So describing our glide reflection would be y plus 4, or more specifically, 4 up. Right? So moving 4 up would opposite this piece first, and then we minus our x's that are all negative now by -1, which would be, again, reflect again back over the y-axis. Reflected in the y-axis. They kind of phrase it like that. So the opposite for that one is just to repeat it. So opposite of 4 down, reflecting over the y-axis, is to start with those endpoints, go 4 up, reflect over the y-axis again. Composition of is on isometry if the originals are isometry. So when we learn 9-7, which is dilation, and we multiply by things, that one would not be an isometry, but the rest of them are. So if we did like a reflection and a translation, right, we just moved and we flipped it, we're still congruent. If we rotated and then reflected, we're still congruent. Right? Endpoints of TV are -2,5 and -4,1 graph double prime after reflecting in the Y, rotation 90 degrees. Now again, reflecting is something we can do mathematically or, right, we could do with the graph. So -2,5, was it 4, -1, -4,1. There's TV, and it says reflect across the y-axis, so reflecting over this, and then we're rotating 90 degrees. So we're 2 away, right? 1, 2, so we go 2 more. We're 2, 4 away, so 2, 4, and there's T prime, B prime, and then it's a 90-degree rotation. So reminder that 2, 5, 90-degree rotation is the X flips to the back while the Y flips to the front and flips its side. Right, so -5, 2. There's our T double prime. Color code again. We'll switch to red being our final image. And then the same idea over here. We've got 1, 4, 1. And so the flip is going to be 1 comes to the front, becomes negative, 4 fills. And we get 1, -1, 4. And there is our G prime, double prime. So that is what that looks like. We could have also done that mathematically, right? Because this one is a little more pattern-based. So reminder, 90 degrees is we go X, Y to Y flips to the front and becomes negative. X is spills. Okay. Next, if we are flipping, right, we're doing a reflection once, and then doing a reflection again over a line parallel to the first line of reflection, it is the same as a translation, basically, of 2D, right? And here's what it is, right? P double prime is perpendicular, right? Because if we are reflecting once, it's perpendicular bisector. Reflecting a second time, we're continually another perpendicular bisector. And so that's why we get 2D from, right? Distance away from the line. And then the other one, another different distance away from the line. So perpendicular twice gives us perpendicular, and P double prime equals 2D, where D is the distance between the two parallel lines. So some little proofs in here and find the value, right? Reflection line K, right, maps GH to G prime H prime, and then a reflection on line M maps the primes to the double prime. HB is 9, DH double prime is 4. Name any segment congruent to HG, right? So reminder, these are congruent to each other, and those are congruent to each other. So HG is going to be congruent to both H prime, G prime, and H double prime, G double prime. Or if you switch the letters around, same thing. What about GA, right? So color code a little bit. GA is going to be congruent to AG. We can't go further with that because even though we have a 9 up here, this distance is congruent to that distance, right? looking at some of our shapes, if we were 3 away from the line, we'd continue 3. We could have another vertex in that same shape that would be only 2 away from the line, so that the points aren't the same distance away from where we're reflecting. Right? So GA is only congruent to A G prime, or G prime A prime. G prime A, sorry, not A prime. Last one, H prime B. What's that congruent to? So we're talking about this distance here. That's congruent to HB and is equal to 9. So it said congruent, so I might as well make them all congruent sides and fix my G that looks like a 6. And there it goes. A couple more pieces about this, because the next slide is very similar. Does AC equal BD? Right, so they gave us 9 here and 4. And so these are equal, these are equal. So 13, does that equal this side? What do you think? Right? So remember, we've got perpendicular here, and we've got parallel. So I see we got a rectangle. If this side's 13, this side must also be 13. Right? So yes. And also, since those lines are parallel, they're not getting further apart. So the distance from one parallel line to its equivalent point for same thing with A to C. Lastly, what is the length of G double G prime? Basically, what's this distance? If this distance is 13, the whole thing is 2 times 13. That's what that 2D is talking about. 13 was the distance between line K and M, so 2D is 2 times. Reflections. So if we have a double reflection, it's the same as a rotation, right? Now notice they would say the double rotation, though, the rotation angle is whatever the measure is between our 2 rotation lines, double. Right? So if our lines are only 20 degrees apart, and we reflect it over one and then reflect it over the other lines, again, that are 20 degrees apart, the rotation equivalent would be 40 degrees. So basically, we're just doubling. So in this case, they're saying this shape was reflected over this line and then reflected again over this line. What would the equivalent rotation be? Right, if they called it a rotation instead, we do 2 times 80 to get 160 degree rotation is the equivalent to this double reflection. And that wraps up today's lesson.